So waveguide is an alternative coaxial cable. It is suitably shaped hollow conductor which may be filled with dielectric material, and it is used to guide electromagnetic wave. Okay, so one of the examples is optical fibers. It is also a waveguide. The only difference between the frequency of operation is the visible electromagnetic range. Optical fiber are increasingly replacing wire transmission lines in communication systems. The material used in fiber are silica glass or silicon dioxide, and a basic fiber optic link consists of a light source, an optical cable, a transmission media, and a detector. That is all for waveguides. So, there are two different things that you need to know about transmission line, and that is balanced and unbalanced transmission line. For balanced transmission line, it is used on two wire open, twisted pair or unshaded pair, like we see from the previous example just now. Same current flows in each wire, but 180 out of phase. Noise oriented signals are picked up by both wires, but because of the 180 degrees out of phase, they cancel each other, called common mode rejection or CMR. Okay. But with unbalanced line, it is used in coaxial lines, the last cable transmission line we see from the previous video. Signal carried by the centered conductor with respect to grounded outer conductor, and balanced and unbalanced conversion can be done with balanced circuit as figure. We will see balanced circuit later, yeah, here. Alright, so this is the converter just now from an unbalanced signal to a balanced signal, and we can use this also to change it back to an unbalanced signal. So balanced circuit consists of these two lines lah, as you can see. Okay, what are the difference between balanced and unbalanced? So with balance, a transmission line consists of two conductors over here and of the same type, each of which have equal impedance along their lengths and equal impedance to the ground and to other circuit. Okay, so what is impedance? So impedance is the opposition of alternating current presented by the combined effect of resistance and reactance in a circuit. So it is a two-terminal circuit element is the ratio of the complex representation of the sinusoidal voltage between terminals to the complex representation of the current flowing through it. So in general, it depends upon the frequency of the sinusoidal voltage. Okay, that is impedance. Along with their lengths and equal impedance to the ground and no to other circuit. Neither wire is connected to the ground, and advantage of the balanced line format is good rejection of external noise when fed to a differential amplifier. So what about unbalanced line? So one of the conductor is connected to the ground. Okay, as you can see from the image, we compare it. One of them is connected to the ground. In electrical engineering, an unbalanced line is a transmission line, often coaxial cable, whose conductor have unequal impedance with respect to the ground. And it is designed to have its return conductor connect to the ground or circuit whose return conductor is actually ground. Any line that has different impedance of the return path may be considered an unbalanced line. Right, electrical characteristic of two-wire transmission line. Capacitors arise between two lines since they are conductors with electrical field, long capacitors. Inductance occurs in each line due to magnetic field from moving charges, and some of the conductors exist between lines since insulator resistance is not really infinite. Equivalent circuit of a small line section shown in this figure. Okay, this figure contains two resistance, two inductance, one capacitors, and one conductance between these wires. Okay, but typically the valuing of conductance and resistance can be neglected, resulting in this circuit. As you can see, it is only left with inductance. All right. So equivalent circuit primary constant of a transmission line. Unique current and voltage wave are associated with electrical and magnetic fields existing in a transmission line. It gives rise to the following parameters: the resistors, the inductance, capacitance, and conductance. Okay, you can read this definition yourself. And all four of the parameters just now, the resistance, the inductance, capacitance, and conductance, are all distributed along the transmission line, and they are represented on per unit length basis. So this series impedance Z and shunt admittance Y of a line per unit length is given as Z equal to resistance plus uh, JW inductance, and Y admittance just now is equal to G plus JWC. So JW is constant, yeah, JW. Okay, but what we really need to focus on the impedance ZO, okay? So this is a surge impedance. It is input impedance of an infinity long transmission line, and it can shown that it is equal to ZO equal to root inductance over capacitance. Okay, the characteristic of impedance or surge impedance ZO of a uniform transmission line is the ratio of the amplitudes of voltage and current of single wave propagation along the line. That is, a wave traveling in one direction in the absence of reflection in other direction, where L inductance reactance of the line and C capacitive reactance of the line. Inductance and capacitance lah for the simpler terms. Okay, this is the basic equation for such impedance just now. Okay, Z is equal to root LC. We can see from the first example over here. Okay, determine the characteristic impedance of a transmission line which has the capacitance 30 pico F 35 pico F per foot and the inductance of 0.25 micro H per foot. Okay, just substitute this value into the equation ZO just now. Okay, our L is inductance 0.25 micro. So when you see micro, it is times 10 to the power of -6, while the capacitance over here, the C, is 35 pico. So pico is times 10 -12. Okay, substitute those two values, you will get a value for impedance. Try it yourself by doing on a piece of paper, yeah, and see how you can get the answer for example 1 using this equation. Same goes for example number 2. Particular cable has a capacitance of 40 picofoot and a characteristic of impedance 70 ohms. So our ZO is 70. The first question asks you to find the inductance. The L just now, L over here. Substitute ZO with 70 ohms and our capacitance with 40 pico FFT. Okay, so you will get the inductance. And try to find try to determine the impedance of infinity long section of such cable.